Assalamu alaikum children. Today we are going to learn about corrosion of metals. Now this falls under the chapter 12, electrochemistry. Under electrochemistry, we have already learned about electrochemical cells and electrolysis. So this brings us to the final part of the chapter, which is corrosion of metals, right? So turn on to page number 100. So if you look around at the objects which are made using metals, you can see that with time most of them have changed. Like, so these objects could be nails made up of iron, then it could be the blade of the mammoty, it could be a knife, or it could be chains, cogwheels. Anything that is made up of a metal with time would change. So what are these changes? As you already know, metals have certain qualities, and luster is one of them, which means they shine. Okay, so with time, when these metals are exposed to the atmosphere, a change called tarnishing occurs. So what is tarnishing? Tarnishing is the metal losing its luster along with time because of exposing these metals into the atmosphere. Another change that would occur is surface turning deterred. So what does this mean? It means that the surface of the metal would not be smooth. There'll be imperfections, there'll be dents, there will be damages on the surface. And then finally color change, right? So subjecting metals to changes such as these when exposed to air is known as corrosion of metals. So remember, being exposed to air is an important component with respect to corrosion. So here's the definition: subjecting metals to changes such as these when exposed to air is known as corrosion. Right. Here is a picture of a corroded metal tube, metal pipe. So you can see there are dents formed in it and there's a color change. And the metal pipe no longer shines. So there you can see that it is tarnishing. The knife you use in your kitchen is made up of steel, and the nails are made up of iron. So if you observe these objects after a very long time, you might see that they have got discolored and they are also decaying. The changes we discussed earlier could be observed. So corrosion of iron or steel which is exposed to air is specifically known as rusting. So corrosion is basically the metals changing because of its exposure to air. And then there's a specific term called rusting, which is defined as corrosion of iron or steel when exposed to air. Right now, let's talk about rusting of iron, right? So iron is the metal which is used mostly by human beings. So it is produced in large quantities. And then iron is also used to produce steel. As you all know, steel is an alloy which is made up of a mixture of metals, right? Right. So iron and steel can be used to make vehicles, the skeleton of the vehicle, ships, bridges, machinery, and many other equipments and products that we use in day-to-day life, right? So if these objects which are made up of iron rust, then it is quite disadvantageous. It is economically disadvantageous, since when you build a ship, you invest a large amount of money, and then after you build it up, if it ends up rusting after a certain time, then it's going to be a loss. So economically, it's a disadvantageous process. So it is important that we understand the factors that affect rusting, like what are the factors that accelerate rusting and what are the factors that can be used to prevent iron from rusting. So now let's do the following activities to identify why equipment made up of iron rust more easily when they are outdoors rather than when they are indoors, right? Okay, now let's look into the very first activity 12.3.1. So, we'll be looking into different kinds of activities to check whether certain factors is essential for rusting, right? So the first factor that we are going to find, first factor we are going to look into is air. So activity 12.3.1, finding out whether air is essential for rusting, right? In order to do this activity, you need two boiling tubes, and then you need cold water, a little bit of coconut oil, and 2 iron nails, a Bunsen burner, and dilute hydrochloric acid, right? Okay, now the iron nails available in our market has a zinc coating. Now zinc is another metal, so zinc is coated on top of these iron nails. So what we have to do is we have to make sure that we remove this zinc coating. So in order to remove that, we have to keep the 2 iron nails immersed in dilute hydrochloric acid for about 10 minutes. Then the acid will remove zinc. As you have already learned, zinc is a reactive metal. Therefore, in sulfuric acid, zinc will oxidize to form zinc 2 plus aqueous ions. Therefore, the zinc coat will eventually be removed from the iron nail. After that, you have to wash it with water. So this procedure has to be followed for every experiment in which we are using iron nails which are brought from the market, right? Okay, now after the iron nail is cleaned from its zinc coat, the first thing we have to do is we have to add cold water to about half the height of the 2 boiling tubes. So both the boiling tubes have to be filled equally. After that, we have to boil the water in one of the boiling tubes. Let's take that boiling tube as B. Once we boil the water in the boiling tube B, so we have to boil it for 5 minutes. After that, we have to immerse the cleaned iron nails into each boiling tube, to A and B. And then we need to add a little amount of coconut oil onto the boiling tube B, which has the water that was boiled, right? So what is the reason for adding a layer of coconut oil on top of this water in boiling tube B? Well, the reason is when there's a coconut oil layer, it prevents the entry of atmospheric air into this boiling tube B. First thing we do is boil the water in boiling tube B. So when we do boil, as you all know, there will be a certain amount of air dissolved in water. So when you boil, this air in the form of gas or vapor will be removed from the water in boiling tube B. So once the air dissolved in water is removed, you add the coconut oil layer, and so you make sure further air around this boiling tube will not mix with the water inside tube B, right? Okay, now once that is done, we leave the boiling tubes to stand for about 2 days. So that is, we allow some time for corrosion to take place, because as you know, corrosion is not an instantaneous process. It takes time. It happens when you expose the metals to air for several days. So you keep these apparatus for 2 days, and then you observe and take note down the observations. So now let's look what we will be observing, right? After 2 days, you will see that the iron nail in boiling tube A has rust forming on it, right? So this rust would be observed in a brownish color, kind of like orange brownish color. So, but then rust will not be formed on the iron nail found inside boiling tube B, right? So those are the observations, right? So what does this mean? What can you conclude from this experiment? So the conclusion of this experiment is that air is essential for rusting, and that is the reason why the iron nail inside boiling tube B did not rust, because it does not come in contact with air. The air inside the water was also removed, and then further the air mixing of air, further the iron nail was prevented from coming in contact with air by a coconut oil layer. Therefore, you can easily understand that air is essential for rusting. Right. Now we move on to the next activity, activity 12.3.2. So in this activity, we try to find out the components in air that are essential for rusting, right? So as you all know, air is a mixture of many things. There are several gases and there's water vapor as well, right? So we try to identify which components in air are essential for rusting, right? So you take 2 boiling tubes, some iron wool and a basin of water, right? Now, in one of the boiling tubes, you have to trap a lump of iron wool, as you can see in the diagram, and then keep it inverted in the basin of water as shown in this figure, right? So you keep both the boiling tubes, only one boiling tube will have the iron wool, right? Okay. And then you have to observe after a few days, right? So when you do observe after a few days, you have to note down your observation. So the observation would be that the water level in tube B with the iron wool has risen, and this value to which it has rose inside the boiling tube has to be noted. So it's going to be about 1/5 of the total volume of air inside the tube. At the beginning, when you inverted this boiling tube, there was a certain volume of air inside this boiling tube, right? But when you observe after a few days, the amount of air inside this boiling tube is less, and that is the reason why water from this water basin would rise up along this boiling tube, right? Because a certain portion of this air, inside this boiling tube was taken up, right? After a few days, for this process of rusting, certain amount of air is taken up, right? So when that certain amount of air is taken up, to fill that empty space, water from the basin will flow in, right? So the amount of air taken up by the iron wool for the process of rusting is equal to the amount of water that has risen inside the test tube, right? So that amount of water is 1/5 of the total volume. So we can see that only a part of air has been used for rusting. So what is the conclusion of this experiment? You already know that composition of the air is a mixture of things, and therefore the composition of oxygen in air is 21%. 21% of oxygen is found in air. So that is approximately 1/5, right? So from this you can conclude that it is the oxygen gas in air that is required for rusting.